Hello students, so in this lecture we will be talking about mainly graphene mechanics. Now while giving the introduction of nanomaterials in my previous lectures, I had talked about degree of freedom and degree of confinement. Degree of confinement is the number of dimensions where there is a transition from bulk dimension to nano dimension. That means if we have any bulk material, then you have degree of freedom 3 because we have 3 axes x, y and z. Now when you start reducing the dimension in one of the axes, so the degree of confinement becomes 1 and the degree of freedom becomes 2. If you confine it to another dimension, this becomes 2 and this becomes 1, and if you confine in all the 3 dimensions, this becomes 0, this becomes 3 and this becomes 0. So the last one is called the quantum dot, and if we have no confinements 3, 0, this is a bulk material, this is a thin film and this is a nanotube. So in another nomenclature, we can also call the degree of confinement as the nano dimension, whereas the degree of freedom as the bulk dimension. So this corresponds to DOC and this corresponds to DOF. Now in graphene, that means if we consider one atomic layer of carbon, that combination of hexagons, so this is actually a graphene sheet. So if you take graphene, then there are basically two degree DOC, or I should say nano dimensions, ND, because it is in the form of a sheet, whereas so it has got 2 bulk dimensions, not 1. It has got 1 DOC and 2 DOF, or bulk dimension. So since it is in the form of a sheet, it follows the first one, this category. Whereas if you roll it, and you form a nanotube out of it, the carbon nanotube, then the degree of confinement, the nano dimension, becomes 2 and the degree of freedom becomes 1, that is only along the length. So there is a change between DOC and DOF where we form a carbon nanotube out of a graphene sheet. Now similarly, if you go to a fullerene C60, so which is in the form of a football with carbon atoms, hexagons of carbon on the surface. Here the nano dimension, or the degree of confinement, is 3, whereas the bulk dimension, or the degree of freedom, is 0. Now let us try to understand the graphene sheet, because it is very much interesting, because a lot of properties of the graphene sheet are being of the graphene are being practically used nowadays. Let us first draw the graphene sheet once again. Hexagons. Now any of the hexagons, other this can be taken as the base hexagon. So let me put it one of the hexagons, so this one as HO. HO stands for the base hexagon. Now the hexagon, we divide it into 6 parts. So 360 divided by 6 is equal to 60 degrees. And then if you take length of each side as A, so it can be divided into 6 equilateral triangles, and length of each side is A. Now we can divide the equilateral triangle into 2 right angles. So let us draw a equilateral triangle. So this is an equilateral triangle. We can divide it into 2 right angles, 1 and 2, and so this one is A, this one is also A. So the hypotenuse is A, and this one is A by 2. This length, this is A. This length is supposed to be A by 2. So A square is equal to this is A by 2. So we would like to find out this length, and say we call it as U1. So according to the equation, A square is equal to A by 2 whole square plus, this is actually U1 by 2, not U1. We take this one as U1 by 2, because we take this one as U1 and this one as U2. So it will be plus U1 by 2 whole square, and then the U1 actually comes out to be equal to root 3a if you do the mathematics. Similarly, the U2, so U1 and this is your U2. Similarly, U2 will be also equal to root 3a. Sorry, yes, this will also equal to root 3a. No, this is U2, not this one. So this is U1 and this is U2. So U1 and U2. So in terms of coordinates, we can write the value of U1 as equal to root 3a 1 0, because it is in vertical direction. Similarly, U2 will be a projection of u2 on the x-axis, so it will be u2 cos 60 degree. So the x-axis will be equal to u2 cos 60 degree, whereas the y-axis will be equal to u2 sine 60 degree. So this is the x-axis and this is the y-axis. So u2, as we have u1 is equal to 310, u2 will be equal to a cos 60, root 3a cos 60 comma sine 60, so that will make it root 3a (1 by 2) and root 3 by 2. So if you put the root 3 inside, it will be a 3 by 2 root 3 by 2 divided by 3 by 2. So these are the coordinates of u1 and u2. So this is your u1 and this is your u2. Now, as we have seen in our last class, the chiral vector C is actually equal to n into the two basis vectors u1 plus u2 and u1 plus n u2. So if we put the values here, the C actually becomes root 3an plus root 3 by 2 am if we take the x-axis of both the cases, and 3 by 2 am. On simplification, it becomes root 3a by 2 2n plus m comma 3 by 2 am. These are the coordinates of the chiral vector. Now, whenever we are converting a graphene sheet into a nanotube, there will be a need to find out the circumference, what it's called the girth, or L. L is nothing but equal to the C square, the chiral vector C, the modulus of the chiral vector C, and that is equal to mu1 plus mu2 dot u1 plus mu2. So on simplifications and putting all the values of u1 and u2 as we have derived it, so the value of the girth, is actually L square. So the value of the girth L, it becomes a root 3 n square plus nm plus m square. Now this girth that we have talking about, this is basically the circumference 2 pi r, So the diameter of it is equal to pi d. So the diameter of the tube is simply equal to L by pi. And the angle of its or the angle or the cadle angle is simply equal to if I find out tan theta, so that is equal to the y by x, as you know. So y, the cadle vector, the y part is 3 by 2 am. Let's go see this one once again. So this is the y part, this is the x part. So we are doing y by x. So that is why it becomes 3 by 2 am divided by root 3 am plus 3 by 2 root 3 an. This is not m, this is n. 3 by 2 am. This is the angle. So simplification becomes root 3 m divided by 2n plus m. Now this value quantity 2 and 1 plus m is very important. I will tell you how. So the angle becomes theta is equal to tan inverse of root 3 by root 3m divided by 2n plus m. This becomes the angle.